Today we learn about operators in quantum mechanics. We proceed, we have to know this term. That means what is operator. So we first define this term operator. You are all familiar with mathematical operations like addition, subtraction, multiplications, and you also know what is the effect of this operation. I mean, what will be the result after these operations. You can take examples also. You are also familiar with differential operators like ddx, where in the bracket your function will be there. Similarly, the second derivative, and I have given also an integral operator. Okay, so these are all operators, and after operations the function in the bracket will be drastically changed. How we can define an operator? We can define it as a rule by which a given function changes into another valid function. So I have taken here an example. Suppose I have a function fx and I have to convert it to another function yx. Then what I will do? I operate by an operator. Here I have taken a cap on the function fx, and this will effectively gives you the new function yx. So you can understand from the example that any arbitrary operator is shown by a cap over a chosen letter, as I have taken here the letter a, and giving a cap gives you an operator. So let us take examples. Suppose I have taken yx, which is a function of 4, 9 and 16, and the other function fx is a function of 2, 3 and 4. So in that case, so the operator which we apply on the function fx should be an operator which can square the function fx. Okay, so that we obtain the relation yx is equal a cap fx. What is a linear operator? So an operator is said to be a linear when it satisfies this equation. Suppose I have taken the operator as a cap, then your equation, your satisfiable equation should be a cap c1 f1x plus c2 f2x is equal to c1 a cap f1x plus c2 a cap f2x. So for an operator to be linear, this equation should be followed. You have seen the constants c1 and c2, so they are only some arbitrary constants. Okay, so we just take an example. Suppose yx is equal to ddx of c1 f1x plus c2 f2x. So your operator here is ddx. So in this case, this differential operator is a linear operator. Why? Because it follows this equation. So which is exactly your rule. Okay, but you have to remind that any operator which squares or transform the given function into higher order cannot be a linear operator. Okay, so what is the basic rule? We call an operator as linear when that it follows the rule as you have learned earlier. Okay,